We've always imagined new worlds waiting for us among the stars, but the real frontier may be the ones we build ourselves. Rethinking what a world can be. The great paradox of space settlement is that the one place in the universe perfectly suited for human life, the Earth, is also the one place we can never replicate anywhere else. Every other world comes with its own baggage. Gravity that's too strong or too weak. Temperatures we wouldn't tolerate even in mythology. Days are too short. Atmospheres we can't breathe. Radiation no life ever evolved to endure. And climates a cycle between unpleasant and fatal. Yet for most of the time, when we imagine settling the stars, we pictured landing on new Earths, planting a flag, and building cities under open alien skies. But the more seriously we study how humans expand into space, the more obvious it becomes that the planets are poor templates for the future. They are rare, they are stubborn, and they are vastly overbuilt for our needs. A settlement of a few thousand doesn't need 6 billion trillion tons of rock under its feet any more than a family of 4 needs a cathedral for a living room. What people need is space, sunlight, gravity we can choose, ecosystems we can tune, and room to grow at the pace civilization actually grows, not in planetary leaps but in steady increments. The space habitat Diaspora is the story of that realization. The moment humanity stops looking for worlds and starts making them, when migration shifts from the hunt for perfect planets to the construction of perfect homes, built where we want them, scaled to our needs, and shaped to our imaginations. And that sounds ambitious. Remember, we already live on a megastructure. We simply never built one ourselves. And it's worth remembering that as we build space habitats, they do not have to stay put. If resources grow scarce, or temperatures run high within neighbors, most habitats can have a starship drive bolted on the back and simply leave, setting out for a new orbit, a new star, or a new beginning, something far easier than moving an actual planet. And yes, planets can be moved and terraformed, and even coaxed into new daylines or adjusted gravities if you're willing to pour enough power. But that's the point. Everything you do for a planet, you can do for a habitat with a fraction of the effort. So today let's explore why, in the long run, it won't be planets that define humanity's place in the cosmos, but space habitats, built in shining swarms from here to the ends of the galaxy and maybe beyond. Why habitats win on physics, engineering, and scalability. The first great advantage of space habitats is simply physical. They use far less mass than planets while offering far more usable surface, and this ties neatly into the chemical makeup of the universe itself. Most of all matter is either dark matter, which we can't use at all, or hydrogen and helium, which are wonderfully abundant but not great for building anything except fuel and flotation. After that comes oxygen, the third most common atom in the universe, but still only about 1 atom in 1,000, roughly 1,000 parts per million. By mass it's closer to 1% of normal matter because oxygen is relatively heavy, but the key point is that oxygen is rare compared to the vast oceans of hydrogen and helium. Yet that limited supply ends up in almost every solid we care about. A water or ice molecule is nearly 90% oxygen by mass, and common minerals like quartz, silicon dioxide, are around half oxygen by mass. Ordinary dirt in general is closer to 50% oxygen by weight. After oxygen, the universe falls off a cliff in abundance. Carbon at about 500 parts per million, neon at 400, nitrogen at 100, magnesium at 40, and silicon at 30. Neon, like helium, is a noble gas and chemically useless for construction, but all that hydrogen and helium can still do us a favor by filling out the honeycomb shooting layers on the exterior of habitats, where their lower density and high cross-section make excellent radiation and debris buffers. In that context, the engineering logic becomes obvious. A rotating cylinder or torus only needs perhaps a meter of hull, steel, rock, regolith, composites, and other options to protect its interior valley from radiation and micrometeoroids. A planet, by contrast, gives you millions of times more mass than you actually need, most of it buried uselessly under your feet. That mass is impressive, but it's expensive to move, impossible to reshape, and largely irrelevant to keep anyone alive. On a planet, your floor is hundreds to thousands of kilometers of rock. A habitat is an engineered shell that does exactly what you need and nothing more. As you noted back in our previous discussion of megastructures, this efficiency alone gives habitats a decisive advantage. But beyond materials, habitats win because they scale to the pace of human growth. Imagine an arc ship carrying 10,000 settlers to another star. For decades, even centuries, The population is small. A whole planet is just not necessary. It's a burden. Terraforming it takes millennia. Pressurizing it takes titanic effort. Shaping its climate takes stellar engineering. And all of it must be done long before the planet becomes even marginally useful. Living under domes generally will require a similar amount of raw materials to space habitats as well. You still need to give them floors and make the dirt and soil over those because the default regolith of the planet is likely less than ideal for Earth ecology, if not outright toxic or razor-sharp particles like we have on the moon. I would guess expanding your domes would be easier than building an equal territory of space habitat in most cases, just not tons. And that's paraterraforming, not terraforming, and it requires lots of extras like orbital mirrors or shades or any of the other appropriate options we discussed elsewhere. They add up, and some just are not realistic without either a horde of robots or a much bigger population you probably have in those early days. To be fair, you probably do have a horde of robots doing most of the work on this, but they'd also be doing most of the work of building a space habitat. And when that small colony does finally grow large enough to make use of a significant region, it almost immediately outgrows it again, because populations expand continuously, not in planetary milestones. The vast gap between 1,000 people and 1 billion makes plants mismatch to real demographic curves. Habitats, by contrast, grow with you. When your settlement needs to double its farmland, it simply builds another agricultural torus. No need to re-engineer an entire world. When you need more housing, you add another cylinder. When you need a bigger environment, you connect multiple habitats by tether to share rotation, resources, and transit. A small community can thrive in a habitat the size of a town, while 1 million people can fill a chain of cylinders stretching across a solar orbit. Scale is no longer dictated by geology, but by how many cranes, robots, and smelters you brought with you. Customizability amplifies this advantage. A planet gives you 1 gravity, 1 climate, 1 atmospheric recipe, and 1 ecosystem, if you're lucky. A habitat gives you whatever you want. Earth normal gravity for most people, low gravity environments for the elderly, infants, or athletes, microgravity for research or construction, and amphibious or aerostat habitats for animal species that never evolved under 1G. You don't just customize the weather or the day length, you customize the biosphere. Dedicated farming habitats, for example, can rely on ultra-efficient hydroponics, vertical agriculture, or algae towers, none of which need to resemble a natural landscape or require anything like a meter of soil. We only put that much dirt on residential habitats because it provides comfortable radiation shielding for humans and their longer-lived animal companions. Crops and livestock, on the other hand, are not worried about cancer risks decades down the line, so agricultural habs can operate with much lighter shielding, with some like orchards or dairies probably needing more. Any farmers or technicians working there can have protection built into their living quarters, workstations, or the tractors and robots that do most of the labor. You can use external tanks of hydrogen or helium as shielding, saving precious structural materials. The key idea is that specialized habitats can be tailored to exactly what they need, and only what they need. Plants, by contrast, offer a uniform environment whether you want it or not. Temperature varies by location, but you can't shorten the day by 20% or dial the gravity down to 1/10 of Earth normal, or swap out an ecosystem on demand. Industrial habs can operate in pure vacuum or microgravity, which is helpful for many chemical and industrial processes. Recreation habs can be jungles, deserts, coral reefs, or landscapes that never existed on Earth. You can do a contained Jurassic Park because, unlike an island, none of your T-Rexes are going to learn how to breathe vacuum. Probably. You can do a lot with genetic engineering. 1 million ecosystems can coexist safely because none of them can invade the others unless invited, and travel between them is cheap. A personal shuttle, or even cables linking rotating habitats into a shared complex that's half city, half archipelago. See our episode on space habitat conglomerations for more discussion of that. Finally, mobility seals the deal. A planet is fixed, an anchor in space. A habitat can move away from hazards or migrate to richer sunlight, cooler regions, or denser asteroid belts. As I noted previously, you can even put engines on a cylinder and leave your neighborhood entirely. Once humans adopt habitats, plants simply cannot compete. They are heavy where habitats are light, slow where habitats are agile, and static where habitats grow dynamically with the civilizations that build them. In engineering, in economics, and in sheer adaptability, habitats win not because they are perfect, but because they are built to evolve alongside us. They are a house, not a cave. Which one do you want to live in? And here's a critical thing we'll talk about more in a bit. To get to any place outside our own solar system, you either have to invent FTL, freeze yourself, or get used to living in a rotating habitat for decades or longer. So a lot of time you already got adapted to a space habitat before you ever reached an alien planet, and might decide on arrival you like the idea of living safely ensconced in armored habitat rather than one with a wide open sky. And I will note that having artificial gravity like we see in sci-fi would not noticeably change things versus spin gravity from rotating habitats. The birth of a habitat civilization. If humanity truly begins drifting off Earth in large numbers, it won't happen all at once. It won't start at Mars or the moons of Jupiter. It will begin just a few hundred kilometers overhead, in a near-Earth industrial belt that emerges as soon as we start treating space not as a place to visit, but a place to build, work, and live. The first wave of migrants into the space habitat diaspora won't be pioneers carving out lonely outposts. They'll be workers, researchers, families, and entrepreneurs who move upward because there's jobs up there and purpose up there, and life in orbit is better, safer, cleaner, more comfortable, and more customizable than anything a frontier planet can offer. There will always be pioneers who seek to go to the dangerous frontier, and that will help us to expand our reach in the galaxy. But for most people, especially people with families, a nice, comfortable habitat close to hand is preferable. The architecture of that early era will feel familiar: O'Neill cylinders, Stanford tori, burnospheres, and initially more modest drum habitats, von Braun wheels, and Kaplan stations, each a small world, each with its own population, its own light cycle and climate. Some will be residential communities built to feel as close to Earth as possible. Others will be industrial hubs built for vacuum manufacturing, recycling, solar power harvesting, or asteroid smelting that a modest habitation drum or ring has been attached to. Many will be hybrids, gradually expanding as their populations grow as their robotic construction fleets scale. And crucially, this growth does not require terraforming or waiting centuries for a planet to become habitable. Every new settlement begins as a single structure: an Hulk ship arrived from Earth, a factory spun from lunar regolith, or a free-floating habitat seed from an asteroid or carved into one. As more people arrive or more children are born, you add another cylinder, or a farming ring, or a low-gravity recreational habitat. Maybe you did all your residential and agriculture in one initial one, and you built an agri-hat to provide more food, while converting the farm section of one of the originals into more residential neighborhoods. A civilization built from modular pieces can grow the way a coral reef does, organically, creating new structures as needed, spreading to whatever orbital niches offer sunlight, materials, and safety. It also grows outward rapidly. The industrialization of the moon's surface, the mining of near-Earth asteroids, and the expansion of solar power satellites all feed directly into more habitats. Each new structure is both a home and a factory, capable of printing more of itself. Before long, Earth's orbit becomes a continuous chain of interconnected worlds, linked by tethers, short-hop shuttles, and quiet, personal spacecraft that can dock anywhere on the rim of a rotating station. You park under your house on the outside of the space habitat and then take an elevator or stairs up to your basement in your home. So travel between habitats becomes no more exotic than commuting to another burrow. And as that web thickens, Earth subtly shifts from the center of human population to the center of human history. The diaspora isn't a sudden leap, it's a slow tipping point. Earth remains a cultural treasure, a place of pilgrimage, a biodiversity vault, and a political heavyweight, but it's no longer where most people live. There's just so much more room in orbit, and nobody's locked in as neighbors in new space habitat. Gravity is optional, night and day are programmable, ecosystems can be built for functional beauty. Over raw agricultural production, since you have to worry about wrecking the local ecosystem. You built it after all, and you're not knocking over forests that have been there for centuries. And unlike any planetary colony, a habitat can be repaired, refitted, resized, or replicated without changing the laws of physics under your feet. The Hill sphere of Earth, the region where you keep things orbiting it rather than the sun, is immense, and all within a light second or two of Earth. And it gets tens of thousands of times more sunlight than Earth does to light and power habitats. That's a volume, but the light is a cross-section, so even when fully populated, it's not very dense, the natural rural or suburban fringe of Earth, and ultimately vastly bigger in potential. One built there can be shipped off to asteroids and moons and orbit other worlds, or you build them near those places to begin with. Both methods can make sense. Indeed, one can't imagine an asteroid mining base growing rich in supplying materials, and as it neared exhausting them, deciding to migrate back to Earth with the whole habitat to take up some new industry. This is the birth of a habitat civilization, humanity that grows by building new Earths as needed, each tuned to a purpose. A galaxy where the first great wave of settlers never lands anywhere, because they don't need to. The places they live are not destinations, they are vehicles for life itself, expanding with every generation, forming an archipelago of worlds across every orbit we touch. Today we're looking at humanity spreading beyond planets entirely, living in habitats, stations, and artificial worlds scattered across space. If you enjoy that kind of large-scale settlement thinking, that's exactly what I explore in Settling Saturn's Rings, this month's exclusive. We look at how those iconic rings could become one of the largest construction zones in the solar system, rich in ice, easy to access, and ideal for building habitats, fuel depots, and megastructures like the circumhabitat, stretching hundreds of thousands of kilometers. For several years now, I've been releasing monthly exclusives and bonus content on Nebula, where every episode of SFIA premieres early and completely ad-free. That includes dozens of exclusives and over 800 episodes of SFIA, along with content from hundreds of other creators, like the Practical Construction series from Practical Engineering, which explores how massive modern megaprojects actually get built. Go watch Settling Saturn's Rings and use my link with the QR code to get 50% off an annual plan. Just $30 for the whole year. Life without planets, cultures that grow in steel valleys. Life inside a space habitat is life in a crafted reality. That changes almost everything about culture, politics, and what people think our world should be. In the age of planetary colonies, we imagine awkward societies forming slowly, shaped by harsh landscapes and long isolation. But habitats are not landscapes you endure, they are landscapes you design. A cylinder might decide to run soft morning light for a community that likes gentle dawns, while the next cylinder over prefers a bright Mediterranean blaze at breakfast. Another turns its interior into a rainforest preserve or a continuous vineyard terrace spiraling on a 1,000-kilometer arc. Each habitat becomes a city-state, self-governing, self-sustaining, and distinct. One might focus on academic life, becoming a university hab with tranquil gardens and observatories spaced along the rim. Another becomes an industrial or research center, crowded with labs and fabricators. Others lean into art and philosophy, or into low-gravity sports, or into religious retreats designed around their own custom day length. When you can choose your gravity, your climate, your seasons, and your sky, societies diverge naturally but peacefully, because nothing forces a single culture onto millions of people. And that diversity isn't a bug of habitat life, it's one of its greatest strengths. Even if 99% of the habitats aim for Earth-like environments, that remaining 1% will still number in the billions across a mature Dyson-era civilization. Entire ecosystems designed from scratch, floating kelp forests, trees growing miles high in lower-gravity misty environments, cavern walls lit by bioluminescence, microgravity coral reefs, each exists side by side with pristine nature preserves, engineered to shelter extinct animals or fragile biospheres. And unlike a planetary wildlife preserve, nothing inside a habitat can accidentally escape into the galaxy, except potentially that T-Rex we mentioned earlier. It is the ultimate safe playground for creativity. Most importantly, mobility changes how people relate to each other. If one habitat community finds itself in an ideological conflict with another, they don't have to fight over the same patch of ground. They can simply leave orbit and go elsewhere. A dispute that would have escalated into a war over land, water, minerals, or strategic buffer zones back on Earth instead becomes a migration. Civilizations becomes less about territorial conquest and more about voluntary association. You are not trapped by your geography, you can swap it out. The political implications are enormous, to say the least. Habitats can confederate, succeed, merge, or drift apart depending on their needs at the moment. You can solve a diplomatic crisis by distancing yourself a few thousand kilometers, or changing your orbit, or leaving the system entirely if things go really sour. In the case of irreconcilable internal differences, one group can leave for a habitat freshly made with their shared desires in mind. A mobile society that creates new land instead of finding it is a flexible society, and flexibility is the antidote to war. And also, to be fair, a very good resource to have for winning wars. Resilience. Fragile shells, immortal civilizations. Critics sometimes argue that habitats are too fragile, too thin-skinned compared to planets. And it is true that an individual cylinder is not as sturdy as a million cubic kilometer ball of rock. But a civilization of habitats is far harder to destroy than a world-bound society. A planet is a single point of failure. One asteroid, one supervolcano, one global pandemic, one engineered catastrophe, a single biosphere, a single atmosphere. Everything that can go wrong happens under the same roof. And that roof is simply made of air, and that is all that separates you from space. Habitats, by contrast, are a distributed system. Each one is modular, isolated by vacuum, and designed with compartmentalization in mind. A failure in one section doesn't doom the rest. A cylinder can be sealed, patched, spun down, or temporarily evacuated. All the ground and sea lies between you and a hostile universe, shielding you, not just thin air. And because habitats are small relative to planets, losing one is a tragedy, but not a civilization-ending one. Humanity's eggs are scattered across billions of baskets, not one. Add in layered armor, hydrogen shielding, and external debris nets, and habitats can be hardened to the point where nature's worst hazards, asteroids, solar storms, gamma bursts, supernovae, all pose less existential risk than they do to a planet's exposed, unshielded surface. The vacuum of space becomes an ally, a natural quarantine between worlds. You can shield one with point defense no missile carrying a nuke can get through, and its own spin helps protect it from beam weapons and volleys of munitions aimed at the same spot. And unless your enemy simply wants your destruction and a lot of scrap metal, their offensive options are limited to embargoes or brutal invasions full of such natural choke points that no sane commanding general would ever look forward to it. They do not spell an end to war by any means, but they are much safer against attack than a civilization on the surface of a planet ever can be. Mobility enhances that resilience. If a star becomes unstable, a neighbor hostile, or a nearby supernova threatens a system, or an interplanetary crisis looms, habitats can leave. You don't have to wait for rescue or ride out a planetary cataclysm. You can simply accelerate into a new orbit or a new star system. A mobile civilization is not just peaceful, it's durable. It can retreat, regroup, scatter, and rebuild in ways planets never allow. Over long cosmic timescales, that flexibility becomes the key to endurance. Habitats are fragile individually, if not as much as many people think, but the civilization they support is effectively immortal. The true Diaspora, leaving the solar system. Not counting the first few prototypes, when humanity finally expands beyond the sun's warm cradle, we won't be doing it in cramped metal cans pretending to be generation ships. True, we might send cryoships packed to the gills with future colonists, destined for a system already prepped to receive them, or a vanguard mission meant to deploy critical infrastructure, like unfolding a giant beaming array, as we discussed in interstellar relays, to slow larger vessels cheaply from relativistic speeds. But the main wave of our expansion won't look anything like that. A rotating cylinder or torus is already a starship, one that billions of people will have lived their entire lives inside, long before we ever set course for another star. The great insight to the space habitat diaspora is that interstellar migration isn't a special undertaking at all, it's just another Tuesday. And any drive system able to push them up to even the slowest cruising speed of 1% of light could easily power a fake sun to light them for the duration without using a fraction of the fuel the drive needs to speed them up or slow them down on arrival. Same for if they were traveling a relay system and getting power beamed to them, or backup deuterium or uranium sent in pods to run their reactors. Indeed, if such a relay system existed, it could let them drop off people who changed their mind, or folks at home catching up to join them. You can see that Interstellar Relays episode for the details. But beyond messages for home taking longer and obviously having limited trade options during the trip, they really have no change to day-to-day life. So a habitat that grows discontented with local politics, local resources, or local sunlight can simply fire up its engines and join a migration wave, though it might need an upgrade on maneuvering engines to something much bigger or a huge reflective sail, or maybe there's a business for tugboats who do that job. Some habitats might cluster together into caravans, moving constellations of worlds, each carrying its own culture, history, and ecosystem, able to trade back and forth as they could have low fuel need shuttles and even tethers connecting them, as we discussed in the episode Arc Swarms. Others will drift out as scouts or trade hubs, sailing into the Oort cloud and then pushing onward into interstellar space. By the time these traveling worlds reach new stars, they arrive fully formed. They already have homes, farms, power plants, schools, and industries. There is no scramble to terraform or adapt to alien conditions. They simply set up in orbit and get to work mining comets, building more habitats, or joining whatever growing community arrived before them. Planets in these systems become scenic backdrops, research sites, or occasional resource centers, not necessary real estate. Though if they have materials good enough for cheap and robust space elevators, they may park the colony in geostationary orbit of a new world and expand both laterally from it into an orbital ecology and down the ground where resources can be mined by the gigaton and carried to space by modest amounts of electricity easily gathered from huge stationary solar power collectors or by giant fusion reactors, whatever is easiest for them. Thousands of sister habitats might arrive or be built to form a giant geostationary band down to that world around its equator, unfolding huge solar arrays and each dropping their own space elevators down and using more tethers extending to higher orbits to let ships arrive or depart with more speed and less fuel. And this might see a renewed focus on planets, but not in the absence or lack of dominance of space habitats as a separate path of settlement, rather integrated into them. Thus, even in this case, the galaxies are full of human-built worlds, not human-settled planets. Each star becomes surrounded by a diaspora of thousands or millions of habitats, a vast archipelago of artificial worlds glinting into the night. The Milky Way becomes less of a map of stars and more of a chain of cities in motion. The space habitat diaspora is when we learn that a world is not something you must seek out, it's something you can build. And once humanity learns to build worlds, we are no longer bound to the few planets we find, but free to create as many as we need. Habitats grow with us, they move with us, they adapt to us, they shelter our differences instead of forcing us into conflict, and they give us something plants never could, the freedom to take our civilization anywhere, carrying our homes with us like seeds on the cosmic wind. The future of humanity isn't scattered across alien planets. Instead, it's woven across the galaxy, world by world, cylinder by cylinder, a civilization not discovered, but crafted.